Hey folks, we're going to wrap up section 5.3 with part 3 here, and we've been talking about types of chemical reactions. So there are an innumerable number of possible reactions, but they all fall into some broad categories. We have composition, we have, combination, decomposition, single replacement, and double replacement. Now, here in the last two types are kind of special subcategories, and we're going to talk about redox and then combustion. So redox is short for oxidation reduction reactions. These are the kind of reactions that would occur in a cell. It's either energy producing reactions. They occur in a combustion engine. They happen in batteries, burning fuels to make electricity, hydrogen fuel cells. All of these are actually redox or oxidation reduction reactions. And the key to these reactions are that electrons are transferred from one reactant to the other. Okay, so some of the reactions that we've already looked at actually are also redox, right? So like if we went from magnesium metal to a magnesium ion, then that's a transfer of electrons, okay? Um, And there are some terms to know here. The reactant that loses electrons, we say it undergoes oxidation. The reactant that gains electrons undergoes reduction. Now, one way I can help you remember this is that uh, gaining electrons means you're gaining a negative charge, and so the charge is reduced, right? So if you gain electrons, it's reduction, and it's a reduction of charge. There's also a mnemonic device that helps you remember this, which is oil rig. So oil rig stands for oxidation is losing electrons is the oil, and reduction is gaining is rig. So oil rig can help you. And things that get oxidized have the charge go up. Things that reduced have their charge go down. Okay. And so often these types of reactions will be something that has a metal that turns into uh, part of a molecule. But not only that, but that's the first type of reaction or example that we'll look at. So here's an example of a redox reaction. So we have two, it's balanced. So we have two AgCl, which is silver chloride, plus copper metal will have turn into copper chloride plus silver metal. Okay, so you can see this falls under one of the other kinds of categories, right? This is also a single replacement reaction, but it's also redox, right? Because charges are changing. Um, we can split this overall reaction into what we can call half reactions that show oxidation and reduction explicitly, right? So if we think about the one that um, loses electrons and the charge goes up is getting oxidized, and that would be copper because it goes from neutral to copper 2 plus. And so we can write the oxidation half reaction here as copper arrow copper 2 plus plus 2 electrons. Notice one of the rules is that the both sides of the arrow have to have the same total charge. Okay, so lots of things are conserved and charge is conserved. So plus 2 here and then 2 electrons balances out to be neutrally charged. We can also write the reduction half potential where we have 2 electrons plus silver ions form 2 silver atoms, neutral. Okay, so these are examples of half reactions. So anytime a metal forms into a compound, there's a transfer of electrons, and thus it is a redox reaction. For example, calcium metal and oxygen gas combine to form calcium oxide. Write and balance the chemical equation. Okay, so this is a combination reaction, right? We have calcium metal plus oxygen gas combine to form calcium oxide. So says first write and balance the chemical equation. I have 2 oxygen here, so I need to put a 2 in front of calcium oxide, which gives me a 2 in front of calcium. And now I have a balanced reaction. Write the oxidation and reduction half reactions. Okay, so we have calcium, which turns into calcium 2+, which means there must be 2 electrons also coming off, right? Now, there's technically would be 2, 2, and 4 because there's 2 and 2 here, but we can reduce it to this. And then our other half reaction would be O2, and it's going to form O with a -2 charge, and there's 2 of those. So 4 electrons here. Okay. Now, we kind of answered the third question already, but which one is oxidized and which is reduced? Well, calcium is losing electrons. Charge goes up, so it is being oxidized. And oxygen goes from 0, neutral charge, to negative charge. It's gaining electrons. It's getting reduced. And actually, you can see here that the oxygen oxidizes. Hey, that's exactly why it's named what it is. Okay, oxygen oxidizes calcium. Here's another way to think of this and to see it's not always so obvious that transfer of electrons has occurred. Here is a combustion of methane and oxygen, which is also a redox reaction. So one way that you can think about a redox reaction is that for reactions of organic compounds containing mostly carbon and hydrogen atoms, oxidation occurs with the increase in oxygen or the decrease in hydrogen, and reduction is a decrease in oxygen or an increase in hydrogen. For example, methane, CH4, loses hydrogens and increases oxygens, right? Because it goes to CO2. And so that's being oxidized. Also, you can see it's being oxidized by oxygen in the reactants. But it's increasing in oxygen and decreasing in hydrogen. And this reactant decreases by 1 in oxygen, but increases by 2 in hydrogen. So it is being reduced. So we get the same result that oxygen is reduced. The other reactant is oxidized by oxygen, but we can do it by looking at the numbers of oxygen here. Okay. So basically, combustion reactions here are a special type of a special type, right? They're special types of redox reactions in which one of the reactants is water, oxygen. The products are carbon dioxide and water. We've practiced balancing a few of these, but let's do a few more, and we'll finish with these. So I think we've done even octane. So let's see if you remember, or if you can do it again. Write and balance the combustion reaction of octane. So it tells us up here, and one of the reactants is oxygen, and it tells us what the products are. So we have C8, H18, plus O2, forms CO2, plus H2O. So for a combustion reaction, we always want to start with carbon, and we have C8 in octane, so we're going to put an 8 here in CO2. And then we have 18 hydrogens and water. Each water has 2, so we need 9 of those to balance out hydrogen. And now we have 16 oxygens here, 9 oxygens here for 25. And so we could put 25 halves here, right? But ultimately we're going to have to double everything. to get rid of the fraction. And there we go. All right, let's do one more. This one's a little bit different because we're going to do the combustion of methanol, which has oxygen in it. So we're still going to set it up the same way, CH3OH. So you could write this as CH4O, but we usually don't because of the way that it's actually arranged is like this. And so by saying CH3OH gives us more information about how it's put together like this. So CH3OH has 4 hydrogens and an oxygen. That reacts with oxygen to form CO2 plus H2O. Okay, so let's take a look at carbon. Carbon, there's 1 and 1, so carbon is balanced. Hydrogen, we have 4 here and only 2 here. So if I put a 2 here, now hydrogen is balanced. So let's look at oxygen. So here we have 2 oxygens and 2 oxygens for 4. Here's 2, here is 1. So we have a total of 3. Okay, so that's not going to work. So we have to double everything, right? Do you see why? There's nothing we could. Oh, we only have O2 left over to add because if we add methanol, we're going to change everything else. So we're going to put a half here to get 1 more, or essentially we're just going to double everything. So if I put a 2 CH3OH, I'm going to leave this blank for now. So 2 CO2 and 4 H2O. Then now I have 8 oxygen on the product side because I've doubled it. I have 2 here from methanol, so I need 6 more, and so I will end up with a 3 here. I'm sorry, before I think I said 1/2. I said 1/2, but I need 1/2 more. We already had 1, so it's 3 halves there, which gives us 3 O2. So that's the balanced combustion reaction of methanol, which is a special type of redox reaction, which has to do with transferring electrons and changing the charges on things. Okay, so we've gone through a lot here in this section: the combination, decomposition, single replacement, double replacement, oxidation reduction, and combustion, and reviews these to balance equations. So that wraps up chapter 5. I want to remind you of some resources in your textbook. On page 177 starts the core concepts. Key terms start on page 178, and there are additional exercises on page 179. And don't forget sapling, homework, and learning curve, which are always available. Okay, until next time, take care.